In this lesson, we want to talk about conic sections. And here specifically, we want to focus on the ellipse. All right, in the last lesson, we talked about the parabola. And specifically, we learned a new geometric definition for a parabola. We learned that no matter where we were on our parabola, that given point, that given x comma y ordered pair, is the same distance away from a fixed point called the focus as it is from a fixed line called the directrix. Now, when we get into talking about an ellipse, we see the concept of a focus again, but now we're going to have two of them, so we're going to call it the foci. Okay, so that's for two. And basically, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, these foci, is going to be constant. When we work with an ellipse, when we start looking at these equations, you're generally going to start out with ones that have a center at the origin. This is the easiest case scenario, and then you're going to look at shifting this for harder problems. So we're going to start out with x squared over 25 plus y squared over 9 equals 1. And what I'm going to do is I'm going to go immediately to the coordinate plane where I've already graphed this, and I'm just going to walk you through some of the terminology that you're going to see in this section. This is not something that's very difficult to kind of work with, but there's a lot of terms that you have to remember, so it's more of a kind of tough vocabulary lesson where you just have to memorize a lot of stuff. So the first thing is, let's write our equation again. We have x squared over 25 plus y squared over 9, and this equals 1. Okay, so the first thing I want to talk about would be this point here and this point here. So where did those guys come from? What do they mean? And basically, if you think about this, these are the x-intercepts, right? So in this case, because our center is at the origin, these are the x-intercepts. How do I get the x-intercepts? I plug in a 0 for y. So if y was 0, this whole thing would be gone. I would have x squared over 25 equals 1. Now, when you work with the standard form of an ellipse, you're always going to have 1 on the right side. So this denominator here, if I multiply both sides by it, it's always going to set up to x squared equals 25, okay? Now I solve this with the square root property by saying I have the positive square root of 25 and the negative square root of 25, so that's 5 and negative 5. So let me erase this real quick. I can just say, and I'll just write this real fast, so y squared over 9, I can just say that for my x-intercepts, that I basically take the square root of 25, which is 5, and then comma, y is 0. And then I take the negative square root of 25, which is negative 5, and then comma 0. Okay? So the quick way to do that is just to look at this number right here, this denominator, under your x squared term, and just say, what's the principal square root? What's the negative square root? So if y is 0, you've got the principal square root. If y is 0, you've got your negative square root. So that's how you can get that quickly. You can use a similar thought process to get your y-intercepts. So here and here. So now x is 0 in each case. Okay, x is 0 in each case. And now what's the principal and negative square root of 9? So 3 and negative 3. Okay, so 3 and negative 3. Okay, so now we have those values. We know where those points came from. Now, let's talk a little bit more about the terminology. Because this ellipse is what we say a horizontal ellipse, it's short and fat, right? So it's stretched more horizontally than it is vertically. What happens is we call this line segment from right here, from negative 5, 0 to 5, 0, the major axis, okay? And the endpoints of the major axis are known as the vertices. So I'm just going to say this is a V here for vertices. And then the shorter axis, okay, so from this guy right here, which is 0, 3, down to this guy right here, which is 0, negative 3, that line segment there, you can call that the minor axis, okay? And those endpoints are known as the covertices. So C and then V, okay, covertices. So again, a lot to remember, just something you want to take for your notes. So the longer one, that's the major axis. The shorter one, that's the minor axis. When we work with this guy generically, what's going to happen is we're going to label the distance from the center to the vertex, okay, this vertex over here. We'll call this distance A, okay? We'll call the distance from the center to one of the covertices here, we'll call that B, okay? So we can show mathematically, and I'm not going to go into this, that C squared, okay, and C is going to be the distance from this guy right here to one of your foci, okay, I'm going to call that c, c squared is equal to a squared minus b squared, okay? So what happens is I can call a 5, right? Because the distance from here to here is 5 units, right? If I go from here to here or from here to here, it's 5 units, right? So a squared I know is 25, and b squared, again, b is 3, this is 3 units, so b squared is 9. So 25 minus 9 is 16, so c squared is equal to 16. If I take the principal square root of this guy, because I'm thinking about a distance, it's going to be 4, okay? So the focus here would occur, let me just kind of erase this because everything's just getting kind of jammed up here. The focus would occur 4 units to the right of this guy and 4 units to the left of this guy. So your focus, or your foci in this case, because you have 2, you would have 4, 0, and then you would have negative 4, 0, okay? So that's where those 2 points came from. Now, your foci are always going to occur on the major axis, okay? Always going to occur on the major axis. So now we know where all these points came from. We know where these 2 came from, okay? Again, these are the vertices or the endpoints for the major axis. We know where these 2 points came from. Again, these are the covertices or the endpoints for the minor axis. And then these guys right here are the foci. Again, we know that c squared equals a squared minus b squared. Now, generically, let me give you a formula. So if we see x squared over a squared plus y squared over b squared equals 1, and a is greater than b, this is going to be a horizontal ellipse, okay? Think about what we just looked at. Here, 25 is greater than 9, okay? Think about the fact that we took the principal and negative square root of this 9. Just think about the principal square root. The principal square root of this guy is bigger than the principal square root of this guy. So if we're thinking about from the center going this many units to the right, and from the center going this many units up, well, if this kind of square root gives me a distance, if this amount as a distance is greater than this amount as a distance, it's horizontal, because if this number is bigger, it's stretched further horizontally than it is vertically, okay? So in this particular case, your vertices are given as what? All I have to do is take the principal and negative square root of that guy. So I would say a, 0, and then negative a, 0, and I'm good to go. The covertices, all I have to do is take the principal and negative square root of that guy. So 0, b, and then 0, negative b. And then the foci, okay, remember it's c squared equals a squared minus b squared. And then what happens is once you find that value of c, you're going to say you have c, 0, and then negative c, 0, okay? So you can plug in and figure that out. So now let's talk about a vertical ellipse, because things are going to change. So most books are going to keep a as the larger number, okay? So a is greater than b. So they're going to switch this up and say, this is a squared and this is b squared now, okay? So things are going to change because in this particular case, the vertices, again, because this is larger, it's going to involve taking the principal and negative square root of this number, okay? So the vertices, I'm going to change this up, and now 0 here and 0 here, and I'm going to put a here and negative a here, okay? So it's just something you got to get used to. The covertices, now I'm going to erase this and this, and I'm going to say that I have b and negative b, 0 and 0. And for my foci, this is going to change, and I'm going to say 0 and 0, c, and negative c. Let me make that better, okay? So again, it's always going to be the case that c squared equals a squared minus b squared. Make sure that you assign a properly. So a is going to be greater than b if you want to use these formulas in this setup. All right, so let's look at an example of a vertical ellipse. So we see x squared over 16 plus y squared over 36 equals 1. So this is larger than this. So that's how I know we have a vertical ellipse. Because when I take the square root of 36, it's 6. When I take the square root of 16, it's 4. So think about it. I'm traveling from the center, okay, from the center. I'm going to go up 6 units, okay, up 6 units. And I'm going to go down 6 units. I'm going to go down 6 units. From the center, I'm going to go to the right 4 units. And I'm going to go to the left 4 units. So this guy is stretched more vertically than it is horizontally. So that's why it's a vertical ellipse, okay? Now let's think about some points here, and we'll look at the graph in a minute. So the vertices, again, these are the endpoints for the major axis. Now your major axis is going to be involved on the y-axis, okay? And so what we're going to say is that it's going to be 0, comma, square root of this is 6, and then 0, comma, negative square root of that is negative 6, okay? So again, if I start at the center, I go 6 units up. Start at the center, I go 6 units down, okay? Then the covertices, again, now that's going to be on the x-axis, okay? So I'm going to have square root of this guy is 4, comma 0, and then the negative square root of that is negative 4, comma 0. Okay, so again, start at the origin, and you go 4 units to the right. Start at the origin, you go 4 units to the left. Then again, for your foci, you want a squared, and then you want b squared. Remember, c squared equals a squared minus b squared. Assign these appropriately to where a is greater than b if you want to use this formula. So I know that 36 minus 16 is 20. Okay, so I would have c squared equals 20. Okay. Now, technically, c is a distance if we want to think about it this way. So if I take the square root, I really only want to do the principal square root. But to fill out this kind of information here, I want to do the principal and the negative square root just to make things faster. So I'm going to say that c is equal to plus or minus the square root of 20, okay, just to get these coordinates. So it's going to be 0, comma, whatever that is, and then 0, comma, whatever that is, okay? So this is going to be, if you simplify it, c equals plus or minus. This is 4 times 5. And 4 is a perfect square, so that's 2 times 2, so you can pull that out. So plus or minus 2 times square root of 5. So you have 2 times square root of 5 and negative 2 times square root of 5. Again, c is technically a distance, okay? But you're traveling from the center to 2 times square root of 5, right? You're going up. And then you're traveling from the center down by 2 times square root of 5. So that's how you get those coordinates. Okay, so let's copy this. And let me erase this. And I'll just go through and label some points real quick. So we have the vertices, again, 0, 6 and 0, negative 6. So you see 0, 6 is here and 0, negative 6 is here. So again, these are the vertices because this line that's purple here, this is your line segment that's the major axis, okay? From 0, 6 down to 0, negative 6. This is longer than this one, okay? So that's why this is the major axis. That's why these are the vertices. Then the covertices, I don't know if this is readable here. Let me just kind of erase this and I'll move this up. You got 4, 0 and negative 4, 0. So 4, 0 and negative 4, 0. Okay, so those are your covertices. Again, that's the label we give for the endpoints of the minor axis. Again, this one's shorter than this one. So let's get rid of that. We've already plotted that. And then your foci, again, these are always going to be on the major axis. 2 times square root of 5 is about 4.472. So you can just go from 0 up to about 4.5 and say that'll be your point. And then from 0 down to, again, negative 4.5. Okay, it's not going to be that, but I'm just giving you an approximation that you can look at on the graph. Okay, we're not going to be able to actually plot that using kind of a scale with integers. Okay, so we've got everything plotted. Once you've done that and you've labeled everything, you just sketch your curve, right? So you're done. And basically you want to, just to reiterate this, think about the center here as the midpoint between these two covertices, okay? And it's also the midpoint between these vertices. And it's also the midpoint between these two foci, okay? So if you're ever asked what's the center and you're given the vertices or the covertices, you can figure it out with the midpoint formula. Okay, so let's talk a little bit about shifting things around now. We're just going to look at an example. We have the quantity x minus 1 squared over 25 plus the quantity y plus 1 squared over 16 equals 1. Now, the first thing I'm going to tell you is just think about the formula I just worked out with you and then just shift things, okay? So how does this shift? Well, because everything's wrapped in parentheses here, you think about things as the opposite as you would, okay? So this is minus 1 with x, okay? With x, you're thinking horizontally. And again, because it's wrapped in parentheses, you think about the opposite effect. If it's minus 1, I want to think about it shifting to the right one. So I'm going to say this shifts right 1 unit, okay? Now, inside of parentheses here, we've got plus 1. And now we're thinking about y. Y is vertical, okay? So do the opposite of what you think. It's plus 1, so that's going to shift me down 1 unit, okay? So shifts down 1 unit, okay? So think about this just as you would if it was centered at the origin, okay? What would we do? Well, we know this is horizontal because this is larger than this, okay? So my formula is x squared over a squared plus y squared over b squared is equal to 1, okay? And I know that my vertices will occur where? Well, again, I'm just going to take the positive and negative square root of this guy. So it's a comma 0, and then negative a comma 0. Okay, well, in this case, this is 25. Square root of 25 is 5. So it's 5 and negative 5, okay? So we'll shift this stuff in a minute. This is not going to be the final thing. We'll shift it in a minute, just so you know. Then we have the covertices. Okay, so from our formula, again, we turn to this b squared, and we say it's 0 comma square root of this guy, square root of 16 is 4, and then 0 comma negative square root of that is negative 4, okay? And then for the foci, okay, for the foci, let's put f here, we have what? Well, we think about the fact that we have a squared minus b squared, that's what's going to give us c squared. So c squared equals 25 minus 16 is 9. So again, for practical purposes, we know c is a distance, so technically c is 3, but we need negative 3 and positive 3, so just say that it's plus or minus the square root of 9. So we'll say that we need 3 comma 0 and we need negative 3 comma 0. Okay, so let's erase that and let's think about how we can shift things now. So 1 unit right, 1 unit down. So all the x coordinates, if I'm going 1 unit to the right, I just add 1. Okay, so that's all I need to do. So I'm going to erase this and put 6, erase this and put negative 4. I'm going to erase this and put 4. I'm going to erase this and put negative 2. I'm going to erase this and put 1. And I'm going to erase this and put 1. Okay. Then I'm going to shift all the y coordinates down 1. Okay, so I'm just going to subtract 1 everywhere. So this is minus 1 and minus 1. And then this is minus 1 and minus 1. And then this is going to be 3. And this is going to be negative 5. Okay. So let's copy this. So I've got everything pasted here. Let me just go through the points. Again, this is how you would graph this guy. So your vertices, you've got 6 comma negative 1. So 6 comma negative 1. And then negative 4 comma negative 1. So negative 4 comma negative 1. And then for your covertices, you've got 1 comma 3. So 1 comma 3. Then you got 1 comma negative 5. So 1 comma negative 5. And then your foci, you've got 4 comma negative 1. And you've got negative 2 comma negative 1, okay? So your center is right here, and this is going to be at 1 comma negative 1, okay? So everything has just been shifted 1 unit to the right and 1 unit down. Okay, let's talk a little bit about something you might see. You may need to go from general form to standard form before you can graph something. So I'm not going to graph anything else. I think you get the idea of that. It's pretty simple. But I do want to cover how to go from general form to standard form. And I also want to cover how you can get the equation if you're just given some general information. How can you kind of go through the thought process? So with this guy, we've already seen this when we worked with circles a long time ago. You should know that a circle is a special case ellipse where your A and your B are basically the same value, okay? But essentially what you want to do here is just do completing the square twice. So group your x terms together, group your y terms together, okay? Create two perfect square trinomials, factor those into binomials squared, and then set up your little equation, okay? So what I'm going to do first is say that I have 36x squared minus 72x, okay? And plus, I'm going to do y squared plus 20y. And this will be equal to 8. I'm just adding 8 to both sides, okay? So I didn't do anything fancy. You need the variable that's raised to the second power, your squared term, to have a coefficient of 1. When you work with this with the quadratics, you generally will divide everything, right? If you're trying to solve a quadratic equation with completing the square. But here you can't really do that. So what we're going to do is we're going to factor, okay? So we're going to pull this 36 out. And what I'm going to have is x squared minus 2x. And I'm going to leave a little space here because I got to add something. And then plus, I don't have to do that here. So y squared plus 20y. I'm going to leave a little space because I got to add something. This equals 8. How do I complete the square? Again, look at the coefficient for the variable raised to the first power. Cut it in half and square it. Negative 2 times a half is negative 1. Squared is 1. So you add 1 and subtract 1. Here, half of 20 is 10. 10 squared is 100. So add 100. And if I can fit this in, subtract 100. Okay, so what do I do about this? Well, it's inside the parentheses, so to close this down, I've got to distribute the 36. So what this would look like, okay, is 36 times, I'm going to say x squared minus 2x plus 1. I'm going to distribute this to the negative 1, so minus 36. Then moving on, we'll put plus. There's nothing out here, so I can just say y squared plus 20y, and then plus 100. Again, I can just close this down because nothing's out here. Then minus 100 equals 8. So negative 36 minus 100 is negative 136. So let me scroll down a little bit. We'll rewrite this and say we have 36 times the quantity x squared. Or actually, let me just go ahead and factor this. This is x minus 1 quantity squared. And then I'm going to skip this for now. I'll get to it in a second. I'm going to say plus, you've got y plus 10 quantity squared. And then negative 36, again, minus 100 is minus 136. This equals 8. And let me scroll down a little bit. So now, add this to both sides of the equation. Okay, so plus 136 plus 136. You're going to have 36 times the quantity x minus 1 squared, plus you're going to have y plus 10 quantity squared, equals 8 plus 136 is 144. To finish this up, you want this right side to be 1. Okay, so whatever this is over here, just divide everything by that. Okay, that's all you need to do. And 36 over 144. 144 divided by 36 is 4. So just put a 4 down here. And then this will stay, and this just becomes 1. Okay, so that's your equation. The quantity x minus 1 squared over 4 plus the quantity y plus 10 squared over 144 equals 1. Okay, let's talk about one more type of problem that you might encounter. You might be told to get the equation given the vertices and the foci. Now, how could we do this? We want something like this, x minus h quantity squared over, and this guy would say it would be a squared plus y minus k quantity squared over b squared equals 1. Okay, how am I going to get the center, the h comma k? Well, again, if I think about the vertices here, you got 11 comma negative 8, and you got negative 9 comma negative 8. Well, here's 11. Okay, I'm just going to put this as 11. So 11 comma negative 8 would be something like right here. And then negative 9 comma negative 8 would be like right here. Okay, so we know that if these are the vertices, okay, we know that this is going to be a horizontal ellipse, okay? We know that because the vertices are the endpoints of the major axis, and the major axis here is running horizontally, okay? So additionally, we know that the midpoint, okay, of this line segment is the center. So if you wanted to kind of count this out and cut it in half, you could, but I mean, really the easy way is just to eyeball this and say, okay, well, 11 minus 9 is going to give me 2, and then 2 divided by 2 is 1. So it's 1 comma negative 8. That's going to be the center. So I can erase this and put a 1, and then I can erase this and go minus the negative 8 is plus 8. Now additionally, we need a squared and we need b squared. So how do we get that? Well, a is the distance from the center, which is 1 comma negative 8, okay? So the distance from the center to one of your vertices, okay? So it can go, you can go either direction. So it's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So A is 10. And again, you can just kind of count this. You don't need a graph. So if A is 10, I know A squared is 100. And to get B squared, I use my little formula that C squared, okay, is equal to A squared, which is 100, minus B squared. Okay. So what's C squared? Again, C is the distance from the foci to the center. So just take either one of these. So I'm going to say from 9 to 1 is going to be 8 units. Because again, if I plotted 9 comma negative 8, that's going to be right there. Okay, so the distance from here to here, it's 1, 2, 3, 4, 5, 6, 7, 8, right? 8 units. So you can count it like that, or you can just eyeball it and do it. It's pretty easy. So we know if it's 8 and I square 8, I get 64. Okay, so this is 64. And you can easily see that this is going to be 36, right? So if you subtract 100 away from each side, this would be what? It would be negative 36 is equal to, let me make that better. You'd have your negative b squared, divide both sides by negative 1, and you'd have b squared equals 36, right? We don't need b, we just need b squared. So this is 36. And then we're done, right? We have our equation. And basically, it's the quantity x minus 1 squared over 100 plus the quantity y plus 8 squared over 36 equals 1. So we know that this guy is going to be a horizontal ellipse, and we know how to go through and get what's missing, which is the co-vertices, okay, we can kind of label everything and then sketch a nice graph.